Hazards Identifications and Risk Assessment in Port Berth Construction, a Case Study. Abstract: Port and harbors are the basic infra for the logistics and transportation of goods for international trade. India Peninsular, the 16th largest maritime country of the world, surrounded by Bay of Bengal and Indian Ocean, i.e. 7,517 kilometers. As a result, there are 13 major and 205 minor and notified ports available. In financial year, the traffic has been increased 2.09%. Keeping an eye on the upcoming traffic load, the Indian government has taken up Sagarmala program. Under the program, government has envisioned 189 projects for modernization of ports by investing Rs 1.42 trillion. The sector is facing a lot of risk in terms of life and environment protection while expanding the same. To make the expansion fruitful, and the expansion projects involve heavy cranes, huge manpower, huge expertise and experienced managers, engineers, supervisors, etc. During the execution of activity at various sections, numerous hazards exist which may impose harm to the deployed employees and surrounding if adequate measures not taken. This paper describes the hazards in Port Berth Construction at Visakhapatnam Port Trust with preventive control measures to avoid incident, accident. Keywords: piling, diaphragm wall, dredging, drowning, safety, electrical, mechanical, barge, training, fire. 1. Introduction. Indian construction industries plays a vital role in the economy of the country. Robust construction setup and good safety practice is the strength for quality product. It takes months, years to ensure good safety practices, to build up safe working culture and maintain an organization reputation. But an incident might be a catastrophic agent to destroy all reputation, endeavor of organizations, including the direct cost like damage to life of human being, property and environment at a larger scale. Port Berth construction is not easy as other construction activities, as it comes under heavy infra category. Inadequate safety measures may lead to catastrophic major incidents, may result into harm to human being, to environment. It is a moral and legal responsibility of any employer to ensure identification of hazards and take required steps to minimize the risk due for ensuring zero incident at workplace. Hence, review of hazards and required safety measured for each identified hazards in Port Berth construction industry is much more essential to control the hazards. Here, in this paper, we have discussed all the hazard, risk, and task involved while executing the Visakhapatnam Port Trust EQ02-05, 38,916 dm berth construction project. 2 different departments. In constructing the port berth, different departments and sections involved: plant and machinery, store and logistic, quality control, quality assurance, civil engineer, environment department, handling of waste materials and preventing the surrounding environment, HR and admin, purchase and stores, information and technology department, legal and licensing department, environment, health, safety, fire, accounts, planning, commercial and billing. 3 hazards and control measures. 3.1 There are different hazards involved in executing the different activities. Physical hazard, chemical hazard, electrical hazard, mechanical hazard, fire and explosion hazard, occupational health hazard, drowning hazard. 3.2 Reasons of accidents. Reasons of accidents. Reasons: manual handling, objects falling, plant and equipment fall from height 8, 28%, manual handling 5, 17%, plant and equipment -11, 38%. Object falling -5, 17%. 4 Activity involved for executing the project. 1 Dredging, 2 Underwater drilling and blasting, 3 3/5 cage lifting and lowering at borehole, 4 Piling and diaphragm wall, 5 Civil works, 5 Photographs, dredging by excavator, pile boring, /desktop/printout/thesis/photo/06.jpg Underwater drilling and blasting. Diaphragm wall. /desktop /printout /thesis /photo /img_20171228_170906.jpg 35-ton diaphragm. Wall cage lifting. Lifting of diaphragm wall cage. Circular pile. Civil works. Civil works. Diaphragm wall cage lowering into borehole. Civil works. /desktop /printout /thesis /photo /dscn0092.jpg 6. Hazard identification risk assessment. 6.1 Risk rating score calculation procedure. 6.2 Procedure of assessment. The procedure being followed by the ES management team at site. All the section in charge, concerned managers/engineers related to that particular task to be present for the assessment, in which they share the possible hazard that might be involved from their vision, prediction out of their past experience. 6.1.1 Number of person affected, N. 1 person. 1. 2 to 5 person. 2. 5 plus person. 3. Public/vulnerable people. 3. 6.1.2 Severity, S. Severity/effect on health. S. Negligible. 1. Minor. 2. Major. 5. Fatal, death. 10. 6.1.3 Likelihood, L. Likelihood. L. Probable. 0.5. Remote. 1. Possible. 5. Likely. 10. Certain. 20. 6.1.4 Risk rating score, RRs. Acceptable. A. 10. Low. L. 10 to 19. Medium. M. 20 to 49. High. H. 50 to 99. Very high. VH. 100 plus. Very high risk. This risk is intolerable. Immediate action of avoidance and protection needed urgently. Temporary mitigation measures should be taken instantly. An action plan for final solution should be started and take place within 1 month. High risk, preventive and corrective action are to be ensured to decrease the risk are required. Provisional countermeasure should within 1 month and action plan for final solution within 3 months. Medium risk, regular inspections are required to confirm that the risk is in control. Continuous inspection is also required to ensure that risk is not rising further. Preventive and corrective actions can be taken as per need. Low risk, this is green zone which displays that the risk is within tolerable limit. In the zone the risk is under control, regular monitoring of activities and administrative control is necessary. 6.2 Steps followed for the assessment. Step 1. The possible hazards will be quantitatively rated by the factors as mentioned below. IN, number of person affected. 2S, severity. 3L, likelihood. Step 2. The risk rating score would be found out by multiplying above said 3 factors. Step 3. Safety control measures would be taken further to reduce risk. Step 4. Once, again the reduced risk rating score will be calculated. 6.3 Hazard identification of risk assessment for dredging work. SL. Task. R/NR. Hazard. Hazard effect. RRs. Control measures. RRs. N. S. L. RRs. N. S. L. RRs. 1. Dredging by floating barge mounted by crane and backhoe. R. Collision with other crafts. Injury to personnel/damage to equipment/capsizing of floating crafts. 2. 10. 5. 100. A. the trained/experienced master of the dredger must follow approved marine traffic route by taking prior necessary approval from the port traffic authorities. B. Dredger/barge must be fixed with operational, calibrated navigation and communication equipment on board. C. All crew members must wear life jacket during navigation equipped with rescue lifeboat for emergency response. 1. 10. 1. 10. Falling into water. Drowning. 2. 10. 5. 100. A. No working should be permitted during extreme weather conditions. B. Barge should be equipped with handrail, lifeboat, and personnel with all life-saving equipment i.e. lifebuoy. 2. 10. 1. 20. Incoming tide. Drowning of personnel and sinking of barge. 2. 10. 5. 100. Dredger/tug must be barred at the times of cyclonic or extreme condition by following the tide chart and IMD instruction, equipped with all safety equipments. 2. 10. 1. 20. Failure of lifting tools and tackles i.e. wire rope, D-shackle and dog clamps of crane. Property damage. 1. 5. 5. 25. Visual inspection and preventive maintenance schedule must be done to prevent such failures. 1. 2. 1. 2. Electricity. Electrocution. 2. 10. 5. 100. A. Electrical doubly insulated cables must be routed through ELCB 30MA. C. Only trained, authorized and license holder electrician to be deployed. D. Electrical inspection must be done on regular basis as per preventive maintenance schedule. 2. 5. 1. 10. Working at night. Injury to person. 2. 10. 5. 100. A. Proper illumination must be provided as per standard. B. Light ray must not directly focus on face. 2. 5. 1. 10. Noise. Adverse health effect and distraction. 2. 5. 5. 50. A. Deployed equipment should be of good quality. And continuous noise level monitoring to be done as per the standard. B. Administrative control like shifting of deployed person in 6HR, providing earmuffs to be done as per SOP. 2. 5. 1. 10. Worker/staff entering to offshore. Drowning. 2. 10. 5. 100. A. Navigation of barge should start with prior permission from the Traffic Control Department and brief toolbox talk. B. Single entry and exit with register, token system to be followed to ensure people count. C. Ensure deployed trained and experienced must wear life jacket and other applicable PPEs while going to offshore. D. Ensure weather condition is good and barge is equipped with all safety devices. 2. 5. 1. 10. Person being hit by equipment. Injury/fatality of person. 2. 5. 5. 50. A. Project-specific training must be imparted to the deployed trained and experienced pilot and workmen. B. Use proper signaling systems and communication systems to be ensured for all navigation and work must be stopped in harsh weather. 2. 5. 1. 10. 2. Changing of grab. R. Working near water. Drowning. 1. 10. 5. 50. A. Project-specific training. B. No staff working during extreme weather conditions. C. Worker or person should wear life jacket, life buoy, emergency boat should be made available for 24/7. D. Railing on barge must be ensured. 1. 10. 1. 23. Transporting dredged soil by land mode. R. Toppling of dumper/excavator. Injury/fatality of person. 2. 5. 50. A. Trained, authorized, and experienced driver and operator must be deployed. B. Ensure every earth-moving equipment, dumper, tripper, excavator, must have helper with whistle. C. Area to be cordoned off. By displaying adequate poster and warning signages with identified passage, illumination, and traffic marshal at each entry. D. Ensure all safety devices, i.e. reverse horn, rear view mirror, reverse end headlight etc. in working condition. 2. 5. 1. 10. 4. Transporting dredged soil by water mode. Collision with other passing by crafts and barges. Personnel/damage to equipment/capsizing of floating crafts. 2. 10. 5. 100. A. Necessary permission from the port traffic master and other relevant port authorities prior to start the work. B. Deployment of skilled and experienced personnel having sound knowledge of all relevant international navigational safety rules and abides by local regulations. Safe navigation. C. Usage of calibrated navigation and radio communication between land and sea must be maintained during navigation. D. The barge/tug master must adhere to the approved marine traffic route plan. E. To tackle the emergency situations like drowning, extreme rough weather i.e. cyclone, heavy wind flow, the deployed workmen must be trained, wear life jackets. The tugs must have the emergency kit etc. F. No work shall be carried out during rough weather conditions. 2. 5. 1. 10. 7. Conclusion. We have noticed the significant reduction in risk level i.e. RRs, residual risk score, after the analysis. By hazard identification risk assessment we have reduced the risk from high level to low and acceptable level by taking all the applicable safety precautionary measures and preventive measures. Hazard identification risk assessment is a tool to mitigate the risk well before executing the work by analyzing the risk by finding the root cause with all the experts' input. Organizations are nowadays using this HERA tool as a major key player to mitigate the loss of life, property, environment etc. as well as the indirect cost like organization image, problems in bagging the business/projects, man-hour loss etc. Organizations, whether it may be brownfield/greenfield project, process/manufacturing/chemical plant, can use the hazard identification risk assessment as an effective tool and prevent themselves from catastrophic consequences and have better productivity, quality with zero incident.